Good morning, good afternoon, good evening. You are welcome to today's lesson. And in today's lesson, we are going to look at the solution to the assignment given in the previous lesson. Okay, and this was the assignment. Okay, you were given this binary operation data, okay, defined on a set of ordered pairs of real numbers by what you have here, and you were asked to find the identity element or element. Okay, however, we realize that this operation that we have here is commutative, so obviously we'll get only one identity element. So the identity element will be unique, it will be one. Okay, so as usual, okay, what you do, solution, what you write, okay, first you extract the operation and its rule, and you tell us where the elements, okay, are coming from. So some of you forgot to attach this. So I put, okay, an exclamation mark or a question mark there, okay, to tell you, or a question mark, to tell you that there is something missing. Okay, now that you attach this vital information, what do? You are looking for the identity element. Because you are dealing with ordered pairs, your element that you are going to introduce, which is your identity element, will also be an an ordered pair. So you let GH, okay, be the identity element. And I told you, you move alphabetically. It doesn't really matter. You can use, okay, any two letters which are not already used here to represent your element in the ordered pair for your identity element. So at this point, what do? You can write BATS, or this implies that you know any element. So you take one of the two elements given here, okay, two ordered pairs. Okay, I took CD, the ordered pair CD. Operating on the identity element GH should always give you the element itself, or the swap, okay, should also give you the element itself. So the identity element operating on the element should give you the element, and in this case we are dealing with ordered pairs. And again, some of you forgot to attach this vital information. Please make sure you don't forget. So here, GH, you know, these two are coming by way of your own introduction. So you tell us where they are coming from, and they cannot come from anywhere apart from the set that your operation is defined on, a set of real numbers. So you take one of the statement that you have here and work with it, because you know the other statement will equally give you the same result, just because the operation is what? Commutative. Because if you swap these two, you end up getting the same result. Swap these two, you end up getting the same result. Addition is commutative, multiplication is commutative. So in all, everything here will be commutative. So now what do? Okay, you use your operation and its rule. And remember, the rule for the operation is the second of the second, okay, sorry, the first of the second, forgive me, first of the second, okay, plus what? First of the first. That will be your first. So what you have here, so first of the second plus first of the first, so J plus C. Then the next one will be second of the second times, okay, second of the first. So second of the second here, okay, is this, times second of the first is this. So that will give us HD, and that must be equal to this. At this point, okay, you have two ordered pairs being equal. And when two ordered pairs are equal, it means their corresponding elements should be equal. So first element should be equal, and second element should be equal. Okay, however, some of you, when you were equating, okay, the corresponding elements, you forgot this vital information, the connector. You are connecting the two, so it will be J plus C is equal to C, and if this is one is not there, you are doomed. Please take notes. And the words could be comma, but not, okay, even if you connect it with or, but it should be end. Okay, then now what do? Your HD is equal to what's the D. At this point, you come and solve for J, because we are looking for G and H to get our identity element. So here you move this one. And again, some of you divided straight away. I've told you have to write this again before you divide. When you have a monomial on each side, then H will be equal to what? 1. So you draw your conclusion. Therefore, 0, 1 is the identity element. Is my point well made? Is there any concern that you think I have not addressed? Bushra, are you fine now?
Yes,
Bushra, are you fine?
yes, please.
Great. Okay. Let me see whether Alan is with us. Alan, are you fine? Alan, are you fine with explanation? Okay, so this will be it for the solution to the assignment and the concerns, okay, addressed. Okay, so if you don't have any issues, okay, then we will bring the curtains down on the solution, okay, to the assignment.